Hey guys, I hope everybody's doing well out there. We're going to transition into a pretty important piece, especially because we're going to build on this quite a bit when we come back from fall break. It's going to be compound inequalities. I would recommend you get your notes out prior to watching this video. Print them if possible. So if you want to pause it now and get out the notes on compound inequalities, it would be a good idea because we're going to be using those notes and then also writing examples on them as we go through and do it. So if you want to pause now, that would be a good idea. And I'm going to go ahead and get the dot cam ready while you do that. So what I have over here under the dot cam are your notes that are on your Teams page. So the key to understanding compound inequalities is that this is a problem with more than one inequality. Everything we've done so far has been like x is greater than 4 or x is less than or equal to 7. But a compound inequality is going to have more than one inequality. So it's going to be those two, x is greater than 3 and x is less than 7, both of those things. Or you could have something along the lines of x is less than or equal to -5, or x is greater than or equal to 10. Now the key is these situations about inequalities are going to differ based on what kind. So the first thing is we have inequalities that are going to be characterized as an and. Now, the key with an and inequality is it will either say the word and, it'll literally have that in between, or it's going to be an inequality that is all compressed and mashed together. And we'll look at what that is as we move forward. The key for an and is that whatever statement is being made has to be true for both inequalities. And when we're graphing those, because remember, with inequalities, it's always about the graph, you're looking for where graphs overlap. Now, typically, an and is going to point in both directions and then is going to overlap in the middle. So when we have an and, usually what's going to happen is you're going to have something here, and we'll just say that it's going to be at -3, and the arrow is going to point to the right. And then maybe we'll have one here at 1, and the arrow points to the left. So those are going to be the two inequalities that you get. Now, the key is I'm looking for the overlap. And the overlap portion takes place right there. Now, it's important to understand that the open dot in this situation means it doesn't actually overlap at -3, and it doesn't overlap at 1, but it does overlap for everything in between. So if I was going to graph the answer for this, what I would do is I would put an open dot at -3, an open dot at 1, and I would fill in everything in between. So that right there in the purple, that would be the answer for that particular and. All right, because that is where the two graphs overlap. And when we start doing some examples, it'll make a little bit more sense for you. An or is true if either inequality is true. They don't both have to be true. It can be either or. And this is key because I look at this and I think the best way to think about it is the graph is greedy. It's going to take everything that it can. So the more it covers, the more of the answer. If you looked up at this example, we had to have it where the two lines overlap. So you can see I have two lines overlapping. So that makes this the solution. An or is greedy, though, so it takes whatever it can as part of its solution. Now, the key with an and is the and usually meets in the middle and creates a line segment. Ors will usually go in opposite directions. So usually an or would look something like this. And I can have one open dot and one closed dot. I can have two open dots. It doesn't really matter. An or is usually going to present itself with the lines going in opposite directions. Now, there will be some special case scenarios we'll get to later where that necessarily isn't true. Now, if I'm going to graph the final solution for this one, I want everything I can possibly get from these lines. So I'm going to take this one, and that's part of my answer. And I'm going to take this one, and that's part of my answer. And I take as much as the graph as I can possibly get, so I take both lines. And I'm going to use both of them for that. So again, to recap real quick before we move to examples, and if you want to look at the camera right now, I'll kind of give a visual. Let's get rid of this here. An and is usually going to meet in the middle, and it's going to create a line segment with dots at each end, and they can be open or closed. An or is usually going to go in opposite directions, and it's going to take both lines going to the left and to the right. Now, as things get more advanced, that's going to change, and we'll have conversations when that time comes. So let's go back over to the dot cam here. So let's take a look at a couple of examples of how that would work if I was to do it. The first example here is an and we know it because it says the word and. The second one is an or because it says the word or. Ands are either going to say the word and or it's going to compress it all together. And I'll show you what that would look like after we make the graph. Well, let's go ahead. And one of the things I like to do when I start is I like to graph both lines. Now remember, this is an and, so I am going to need to look to see where they overlap. So if we look to see where they overlap. So x is greater than -5. So greater than means open dot and an arrow to the right because that's greater than. And x is less than or equal to 1. So I'm going to put a closed dot at 1 and an arrow to the left. And this is an and, so I need to look for where the two lines are going to overlap because that's where it's true for both of them. Now this is an open dot right here, so this is going to have to stay open because it does not overlap at the -5. I have a -5 on this line, but this one's an open dot, so no. Now this is a closed dot, so I'm going to put a closed dot at 1. And the overlap is all of this portion here. So when I make my final answer, I am going to draw my line segment right in between those two numbers. Now, I mentioned before that an and will also write it as a fully compressed answer. So instead of writing the word and, this inequality, and the nice part is the picture at the end will actually show me this could have been written as -5. And then I'm going to use this inequality symbol and the letter x, because if we go back to the original, x was larger than -5. And this, even though it's written in the other direction, still says that x is larger than -5. But it's also less than or equal to 1. And you'll see that the numbers in the number line tell me how to write that inequality that's mashed together. And we'll see what it looks like when it begins. Let's move to an or. I know it's an or, so I'm taking everything that the graph gives me, and it's probably going to go in opposite directions. So x is greater than or equal to 3. So a closed dot at 3 and an arrow to the right. X is less than -2, so an open dot at -2 and an arrow to the left. This is an or, so it wants everything. So I really have this graph here, and I have this graph here. I'm going to include both of them as that answer because it's going to be both of those lines because it's an or. Let's look at two more examples that are going to require us to do just a little bit more. I have these examples because x is not alone. So one of the things that we're going to have to do is we're going to have to use all our skills from last week, which is going to be solving the inequality. Now, ors are nice because it's just going to be two separate inequalities that get solved on their own. So for this first inequality, in order to get x alone, I'm simply going to subtract 3 to both sides, and I get x is less than -7. Or, let's subtract 3 in this one, x is greater than 1. So I have two separate inequalities that I will then get x alone for both. And now I'm going to graph it. Now remember, this is an OR. I want you to think for a moment, what do ORs usually look like? And if you were thinking this, woo, two separate directions, then you are correct. All right. And I need a -7 out here. So x is less than -7. So open dot at -7 and an arrow to the left. Or x is greater than 1. So open dot at 1, arrow to the right. And if I wanted to give a final answer using some color highlighters here, we're just going to go open dot and arrow to the right, open dot and arrow to the left. Well, let's look at this inequality. Now, the first thing I want you to realize is it's all mashed together as one inequality without a word in it. So I want you to think back from the beginning of this lesson. If it's all mashed together, what kind of inequality is it? Well, I know that this is an and. If they're ever all mashed together, it's going to be an and. Also, based on the fact that it's an and, I anticipate my graph being a segment in the middle. Now, here's the key. When you have an inequality set up like this, I have to get x alone. And in the past, the rule has always been whatever you do to one side, you do to the other. But inequalities like this don't just have a left and a right. They have a middle, a left, and a right. So whatever I do to the middle, I have to do to both of the other sides. So if this is a regular two-step equation, I am going to subtract 6 to begin. Whatever I do to one side, I do to the other. Well, that means I have to subtract 6, but I also have to subtract 6. Because of the way this is written, I have to maintain balance to all 3 parts of the problem. So now I have -10, bring down the inequality, bring down the 2x, the 6's cancel out, bring down the inequality, and 2. I am now going to divide by 2, and I have -5 less than or equal to x, which is less than 1. So here is your inequality all mashed together, solved for the letter x. Now, when we graph it, we have to look at it as 2 separate inequalities. So I'm going to cover up this side of it and just look at that. And what do we know about the letter x? Well, that says that x is greater than or equal to -5. So I am going to put a closed dot at -5 and draw my arrow to the right. Should have left a little more room here when I made this. Now I'm also going to look at the other one. So I'm going to cross out this side. And what does it say about x when compared to 1? It says x is less than 1. So I'm going to put an open dot at 1 and draw my arrow to the left. Well, where is my overlap of the 2 lines? The overlap is right there. So when I draw that final answer, it's going to be a closed dot at -5. It was an open dot at 1. And then I'm going to draw the line segment that connects those 2 dots. And so because it was an and, the overlap happened in the middle, which is what we would have anticipated. All right. I would highly recommend that you go back and look through this if you need to see the examples again. We're going to spend a couple days working on these compound inequalities, and we will review them again after fall break as well. Included in your notes are a couple additional graphing pieces or graphing papers if you need them. And again, we're going to be working with IXL, so some of those graphs will take place online. Hopefully this helps. If you've got any questions, be sure to reach out to me and pop into a Zoom session when we're asynchronous. Have a wonderful day, guys, and I will see you later.